Let's take a look at the repeated nearest neighbor algorithm. Okay, determine the resulting circuit and its weight by applying the repeated nearest algorithm. So we're going to apply the nearest neighbor algorithm, starting at every possible vertex. This vertex situation we have 5 vertices. So we're going to do the repeated nearest neighbor algorithm by doing the nearest neighbor algorithm 5 times. To collect the information, it's nice to make a little table. So we have the start, we will get the circuit, and then we'll look at the cost. So let's start at A. So from A, the cheapest is to C. From C, the cheapest is to B. From B, the cheapest is actually back to A, but then we would have missed out on the other city. So we're not done yet. We can't go to A. That one's not possible. We can't go back to C. So those two are out. But we can still do 53 or, 33. That's cheaper. So let's go to 33. We still have to visit D. It's the only one left to visit. Now it happens to be the cheapest, but regardless, it's the last one to visit. So we have to go to D. And then all that's left to do is get back home. So starting at A, we would have A, C, B, E, D, A. Now if we add up the costs, you can just pull up a calculator. A to C, 4, plus 39, plus 33, plus 10, and finally 51. We get 137 for our weight. Okay, great. That's starting at A. So now we start at B. From B, the cheapest, 39, 53, 33, 32 is the cheapest. Then to C. Then, again, we can't go back to B. Then we go to, the cheapest would be to D. Then we can go to E. And then we complete our circuit. So, B, A, C, D, E, B. So adding those up, we get a weight of 123. So again, you would have, starting at B, 32 plus 4 plus 44 plus 10 plus 33. You can check that, 123. Now we go to C, then we'll do D, then we'll do E. We just keep going. Starting at C, the cheapest is definitely that 4. Then at A, we go to 32. Then we do the 33. Then we do the 10. And last, we would finish off. You might recognize that that's the same picture we just drew. Even though the circuit itself looks different, CAB doesn't look like BACDEB, but it's actually the same picture. Interesting. Starting at D, the cheapest is to go to E. From E, the cheapest is to go up to B. From B, the cheapest is back to A. Then we definitely take that 4, and then we finish the job. Same picture. This one is D, E, B, A, C, D. For the same cost, 123. We keep getting the same circuit even though we're starting at a different vertex. So now we start at E. E, the cheapest, is to D. From D, 51, 53, 44. From 44, from C, definitely do that A. There's only one vertex left to hit, so let's hit it and get back home. Those last two moves should be a guarantee. You shouldn't have to think through what's the cheapest. You've got to hit the last vertex and then get home. And you recognize this fish shape again. We keep getting the same circuit. This one's starting at E. And then it was D, C, A, B, E. Again, 123. All right, before you work on the right side, I want to discuss this a little bit because we're getting two distinct circuits. We're getting this circuit, and we're also getting this circuit. And we got that other circuit four different ways. Oops. So let's take a look at like this E, D, C, A, B, E. That can be reversed, and it'll be the same circuit. We've seen that before. But we can also start at any of these 5 vertices and trace that same picture. So here we start with the E. Let's go to the D. D, C, A, B, E, D. And we can reverse that. D, E, B, A, C, D. And then we can start with the C. C, A, B, E, D, C, and reverse it, C, D, E, B, A, C. And 2 more, we're going to get into the next example. A, B, E, D, C, A, and reverse it, A, C, D, E, B, A. And finally, starting at B, would be E, D, C, A, B, and reversed, B, A, C, D, E, B. These 10 different ways of writing the circuit are all the same circuit. They cross through all the same 6 vertices, 5 vertices and getting back home, so a list of 6 letters, in the same order, giving the same minimum cost. So, there's 10 different possible right answers. This begs the question, which ones do you need to give? Will the computer be programmed to check for all 10 of them? Will the person grading your exam look for all 10 of them? Very commonly, the instructions will say, write your answer starting with vertex A. Now you could do that with any answer wherever you started with, because they're all equivalent. All of these are equivalent circuits, but they ask for them starting and ending at A so that instead of 10 possible right answers, you're only having to look for 2 possible right answers. So let's take a look at the instructions on this next part, and you can see what I mean. Determine the resulting circuit and its weight by applying the repeated nearest neighbor algorithm on the following graph. If multiple unique circuits result, list all of them. Okay? Give your circuit as a list of vertices starting and ending at vertex A. So there's that instruction so that you know of all the possible answers which 2 to write. Now there could be 2 distinct pathways through the circuit that give you the same minimum cost, in which case you list them both. But as we saw in the example on the left, these 4 are actually all equivalent. They're all the same. And so we only list 2 of the possible 10 versions that are in there. Okay, so go ahead and pause the video and see if you can find the answer for the repeated nearest neighbor algorithm on the right. You should have either A, B, C, E, D, A, or the reverse, A, D, E, C, B, A, with the minimum cost of 81. All right, I hope this helps.